Hello, welcome back. Today we're going to use mathematical induction to prove the sum of geometric sequence or progression. So that's the statement we're going to be proving. So obviously n is the positive integer. So we know n is positive integer, means n must be great or equal to 1 minimum. So let's start doing the inductive proval. So we got 3 steps to do. First step, we're going to start with the n equal to 1. So that's the initial, we call initial value. So we need to prove the left-hand side of the statement, which will be r to the power of 1 minus 1, which is 1. So the right-hand side, we can substitute n is 1. So the answer also is 1. So therefore left and equal to right. So therefore the statement is true for n equal to 1. So when we proved initial value, the statement is correct. So now number 2, we're going to start doing some assumptions. We assume the second step is assume when n equal to k, k also is positive integer. The statement is also true. So it means the left-hand side so n replaced by k must be equal to the right-hand side. So that's the assumption. So I'm going to call that's the statement. We're using number 1, equation 1. So then step 3, then we're going to do the next step. So this is called inductive step. So when equal to k plus 1, we also need to prove the left equal to right. So left-hand side is become 1 plus r to the power of 2 plus r cubed plus r to the power of 1. Put that's the first kth term, then I'll plus the next term is a k plus 1 term. So the answer is k. Okay. So this is the first k terms. So I'm going to use the assumption to replace. So the first kth term, the answer will be r to the power of k minus 1 divided by r minus 1 plus r to the power of k. So I'm going to do a little bit simplify. All right, so that's the common denominator. So r to the power of k plus 1 minus r to the power of k. So now if you look at these two be cancelled out, I'm going to rearrange, become k plus 1 minus 1. So that's my left-hand side. So the right-hand side, I arrive to the same conclusion, which is when you replace n with the r to the k plus 1, so that's exactly the same as left. So we conclude left equal to right-hand side. So therefore, we will conclude the statement is true or any n belongs to the positive integer. So that's how you prove statements true when using mathematical induction for the sum of geometric sequence. All right, just ask everybody to subscribe the channel to get the latest update. And thank you for watching. And I'll see you next time. Bye.